Hey, good morning, Geometry Nation. Today we're getting to something special. I wish it was a zebra cake for everybody in the room, but I've got a point of having the zebra cake up here. Okay, I have the honor of introducing the area of polygons. So we've been working on circles lately. We're going to jump to the other shapes, and today they're all going to kind of like come at you at once with a lot of help. All right, so I chose the zebra cakes. Let me reach over here. I chose the zebra cakes. I'm going to hold up the box, right? Originally, the box comes, it's got 6 tasty cake rolls in there. Individually wrapped in this case, 6 individuals, right? Somebody got paid to design this box. There's actually a college degree, package engineering, that you can get. So the creativity that went into this, you can bet this person had geometry in their past. I'm going to open up the box into what is designed to be a single sheet. So somebody with some skills in geometry told probably a computer program to start, flesh out a design, and they said, computer, let's see if we can design something that is one sheet with tabs and features and corners. Those angles would have been measured. If I was going to put a name on this shape here, I don't even know what to call it, but the tabs are trapezoidal in their profile here. One computer program, one engineer, one piece of cardboard, as inexpensive as you can make it to make some profit. The people that design these things, they understand geometry and especially area. Area gives you how much cardboard you're going to need for that project. It can help you calculate how much grass seed you're going to need to cover an unusually shaped yard. So today we jump into area of shapes other than circles. I'm going to take my picture away. And the first thing you see is this green card I hope is being passed out to everybody. All right. I'll tell you a little bit more about only the things we're going to use for now, but this, I want you to hold on to this until the end of the year. Maybe we'll roll it into your folder test that we're all going to get a shot at for a last major grade near the end of school. Flip it over. When there was a geometry star test given to classes in Texas, it's still optional for some schools. This was a reference that was given with the STAR test. You don't need to memorize this. This is now your reference, and you may use it. And in the real world, if I needed the area of a trapezoid, I might look it up on the computer in my pocket and be like, well, I guess I got to figure this out. It's got some letters and some numbers in it. So this is a reference card that gives you something to go on. The other thing you should have handed out this morning is the assignment. And like we've done recently, I am going to take notes and include some examples on this guy. So we're going to work some problems out. But first, I want you all to flip it to the back page, blank on purpose. And we're going to make a few comments here that'll help us. I'm going to write kind of big because I plan on using this entire page for things I can see easy. And I'm going to call this a title here, Area of Polygons. I'm rifling through my school bag. There it is, my own handwriting. These are some notes on the area of polygons. There's not much to tell you. There's a lot of formulas to use. Okay, so that's point number 1. Keep the green sheet handy. All right, there's my big point. I think Mr. Scott and Ms. Sitek and I are all more interested in developing how you think, how you solve a problem, than we are having you memorize everything on a reference card that is given for STAR tests. You're given that to work with. Let's work on the thinking part. All right. What comes on the green sheet? Well, these are simplified formulas. We're only going to write down 3 bullets here. These are simplified formulas, and I'm going to put a little asterisk right there. I'm going to show you what you need for area. Okay, I like this list here. That's my asterisk. Formulas for different shapes. We're going to learn a little bit about the letters. And I like this piece for area here down to here for now. So the top of this side of the sheet, it says page 3 at the bottom. That's just where it came from. The very top of this sheet, okay, and this box, top left. So others, there's more to be had here. We're only going to deal with these 2 and one more piece. Use the key to the terms. And I'm going to put key in quotation marks. Use the key to the terms. All right, and here let's have a different symbol. Let's go double asterisks. The key to the terms is here. Double asterisks. Okay, and I'm making a little, like a spot next to just a few of these. These are the ones we're going to use while I speak to you today. All right, these are kind of simplified versions of formulas because they use a common language that you can learn more about in the key. So it says parallelogram, area is base times height. And I know B times H, they're explained to me here. That's how you use the key for letters, variables column that are in these equations here. Check the key. Okay. I am going to draw freehand a couple of shapes, and I'm going to give you the formula that goes with some that we haven't spent a lot of time with these. Okay, parallelogram. Parallelogram. Area, we just looked at it, equals base times height. Okay, so a star test, the computer in your pocket, it'll give you the formula, but you have to be aware of what these terms mean on the shape. So I'm just going to draw a parallelogram freehand. Okay. And base is kind of what you think for all these shapes. A couple of tricks to think about, but base is often the bottom side of the shape. If you stood this up on its end, this would be on the floor. Okay, and so in relation to a base, this is the height. From this drop to the bottom of the shape, it's a straight line, and this is what they call the height for a parallelogram. It has a lean to it, but it's this dimension here that we use. They'll usually provide you one, or you could measure it in real life. But if you need the height of the parallelogram, think of it like it's truly on the floor. This is as tall as it is because it's leaning. So that's its height. Okay. Triangle. The area of a triangle is 1/2 base times height. Variables written together. These are all multiplications. Okay. Mr. Mitchell, where does this come from? Why is there a 1/2? Well, the simplest way I've ever seen it explained is if I had a square and like a parallelogram, I was going to measure its area, calculate its area, I would do base times height. I would multiply those two. Well, a triangle would split that square. So it makes sense to use 1/2 base times height because of the area that one triangle takes up in this square. That's where they got the 1/2. But there's a little bit of a trick to a picture of a triangle that looks like the classic we saw in elementary school, the classic triangle. This is again my base, but my height is this dimension. Like I had stood it up on its end and measured how tall it was in the room. This is the height on a triangle. How are we doing so far? You in the back of the room. Okay, stay with me. Trapezoid. Okay, this one comes with a couple more letters here. The area of a trapezoid is 1/2 multiplied by the combination of two bases, two base lengths added together, and then multiplied times the height. Base 1 times base 2, or excuse me, base 1 plus base 2. Two bases added, basically finding an average by multiplying them times 1/2 and times the height. Let me show you. Freehand trapezoid. I'm going to fit one more space in by the end of the page here, if you're keeping track of your spacing. I'm making my pictures kind of big. One more. This would be the base, but it's base 1. This is a base. There's two bases on a trapezoid, this one and that one. And height you may find familiar. It's the true height. If I stood this up in a room, this would be how tall it is. The height there. So it is a 90-degree angle with the bases in this case. Here's a piece of advice for when you see 1/2. When I put it in a calculator, I just make it 0.5. It's a lot easier than typing in a fraction. Last shape is quotation marks, a regular polygon. Okay, so in geometry, the regular term means the classic shapes you remember from elementary school. All side lengths are the same. There's beautiful symmetry to the shapes. Stop signs are regular octagons. Okay, so I'm going to try to freehand draw a hexagon here. Hexagon. I need 6 sides for a hexagon. Okay, that's not too bad. All right, here's a new term. Lowercase a is a measurement that would be found in all regular polygons, hexagon, pentagon, triangle. You can draw a line from the middle of the shape to the middle of one of the sides. This makes a 90-degree angle here. This length from the middle to the middle of a side has a name. It's called the apothem. A is equal to apothem. That's the name for this distance. It's kind of like a radius for a polygon. It goes from the middle of the shape to the middle of one of the sides. Here comes the formula. Big A, the area of a regular polygon, is equal to 1/2 multiplied times the length of the apothem times the perimeter, big P. Okay, perimeter. Seen in earlier geometry classes or in earlier math classes, it's good that it's going to come up and be useful for you. The perimeter is the distance all the way around this shape on the outside, like a circumference, but for a polygon, the addition of all the sides together. In math language, I might say that the big P is equal to a side length, because they're all the same side lengths multiplied times the number of sides. That would give you your perimeter. One of the side lengths times the number of sides. So I often draw them when I'm doing these calculations. I draw in to help me count. Yeah, I've got 6 sides. Multiply 0.5 is my favorite, or 1/2, times the length of that apothem, times the perimeter all the way around the shape. I'll show you a couple of examples. So that's it for this sheet. I've put notes on the back of the assignment, and hopefully we all retain these after any grading that happens, and you'll have a nice reference when we take tests coming up next week. Okay, so a couple examples from the front, and you might find yourself working a little faster than you might have. There's memory in there from doing these in the past. This is a rectangle. A rectangle is a parallelogram. That's why it's very, very simplified in this sheet of formulas. These are simplified. Parallelogram. Well, a rectangle is a parallelogram. A square is a parallelogram. They all use the same formula. The area is the base. Here, they just gave us a number for up here, but the same would be down here. That's my base, and this is my height. Equals 3 multiplied by 2.1. Okay, I put that into the calculator for myself to make sure, and it came to 6.3 meters squared, because this is a squared dimension. One dimension of meters times another, they have a unit that is square meters. Not too bad, right? 3 times 2.1. Let's refresh on a triangle. Apologies if I haven't been zooming in enough for you. The area of a triangle is equal to 1/2 base times height. Well, here's my base, and here's my height. So I'm going to say 0.5, which I like for the calculator, times my base of 6 times my height of 4. Cool. If I try it in my head, 6 times 4 is 24. And if I multiply that times 0.5, I take half of it. So without the calculator this time, trying to get smarter as I go, or in my case, just kind of hold where I am in intelligence, 12 feet square. 1/2 times base times height. That was number 3. Let's go down to number 7, a parallelogram. Sometimes they have more information than I might need, but I've checked my reference card. And the area of a parallelogram is equal to the base times height. Here's my base. Here is my height. And I'm not going to need this other telling of what the side length is. There could be extra information in our graphics. Well, I'm going to say 11 times 10. 110, and oh, I've got meters squared. You have enough time today to show your formula, write down the numbers as the problem was set up, and then calculate and clearly box an answer. Ooh, here we go. Trapezoid, and it's got extra information. Watch yourself. Area equals 1/2 the addition of 2 of the bases. 1/2 B1 plus B2 times H. Some of these numbers won't be used. It is equal to 0.5 times, I would put these in parentheses. Add these two together. This is my base, and this number is my height. with the dashes. Okay, so that's 1.9 plus 0.9, close parentheses, and times the height, which is a 1. Be patient. Takes a minute to set it up. If you write out the formula, write out the numbers you're going to use, your mind will run through a cycle of determining what is useful and what is not, and you'll learn better than just firing into your calculator and not writing down anything. It turned out we didn't use these slant heights, we'll call them. We didn't use those numbers. My calculator returned an answer of 1.4, and this is in miles squared. Good job, team. A couple more things to look at. I'm flipping to the next page. Let's bypass these. I think you'll master those at the top with a little bit of practice. And let's try one with an apothem. And I'm guessing this may be new to your geometry career. There's one more step to calculate. I'm going directly to this guy with all of its sides. It is a regular something. It's a regular polygon. The area is equal to 1/2 times the apothem times the perimeter. I need my perimeter. So I look at this picture and I say, all right, here's a side length of 10.3. Let's see how many sides there are. 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. My big P is 10.3 times 9 sides. 10 times 9, it's going to be close to 90. It's nice to guess before I try it to make sure I have a number that's close to reality. It comes to 92.7. Okay, that's my perimeter. Area is equal to 0.5 times the apothem length. It gives me 14.1 times 92.7. Run through the calculator, 653.5. Hold up, Mr. Mitchell. They don't have any units on this. I don't have to write it. I want you to recognize that this is an area. So when they don't give me it, units squared. It has an area, whatever measurement it is. If you put units squared, you'll practice the concept. Nice job, team. Let's look at 18. They just gave me the words. It's a regular pentagon. I need the area. It has an apothem and a side length. Okay. The area of a regular polygon is 1/2 times apothem times perimeter. Let's look at the perimeter. Perimeter tells me pentagon. If I'm not sure how many sides a pentagon has, I would ask. I would figure it out for certain. It has 5 sides. So I'm going to multiply 5 times the length of the side, and that's 16. And that comes to 80 units of length. Now I plug it in. 0.5 times my apothem length of 11 times my perimeter of 80. You might find that you're enjoying these a little bit. That's a guess. Some of you will like being formulaic around it, about it. It's nice to fall into a predictable rhythm here. My calculator tells me this is 440 meters squared. Okay, we're at about 25 minutes. The finish is to just pause and think big picture for a second. We're practicing the area of a polygon. I think somewhere in your life, you might think of your career here at Rockport Fulton High School and you'd be like, oh yeah, somebody told me that I could figure out the area of whatever it is I need to do. Sheet metal that goes on this barbecue, paint that goes on a house, grass seed to plant some new grass. Area can be useful. We started off with some of the shapes you may have remembered from your past. Rectangle, parallelogram, square all have a base times height. Triangles is 1/2 base times height. We got into some shapes we haven't seen for a minute. The parallelograms and the trapezoids with examples. And then we brought in a new piece, the apothem. We practiced one that had 9 sides. Be careful in calculating your perimeter and then follow the formula for multiplying apothem in a 1/2. We looked at an example that was in words that gave us some information. There will be a lot of practice on this because it is one of our newer shapes. And if you've listened this long, a little gift for you on number 24 equals same answer as 16. In my class, if you put that down, it means you watched the end of the video. You're all good with me. Thanks for your time, Geometry Nation. Talk to you soon.